Hey guys, this is just the follow-up tutorial video to the one that I posted a couple days ago. Just like the other video, the principles that I talk about right now will be specifically for assignment 7, but can definitely be translated into following assignments and your final project. So, the purpose of this video is just to help you guys navigate the shake table and the MATLAB software in order to find the natural frequency of your specimen, which in this case is the acrylic piece that the professor has cut out for you guys. So, just a small change from the last video. This time around, we're going to have one of the clamps attached to the table and another free one right here. Instead of having to use the cardboard pieces to wedge in between the two clamps, we're going to take the acrylic and place it in between, and then use one of the metal clamps from class and just screw it around the two sides of the clamp just to keep it as tight as possible. Once we have the specimen placed in between the two clamps securely, we're going to grab the motion sensor right here, which will be on the table. This basically acts the same way as your phone did during the in-class experiments, where it measures translation and acceleration at different degrees of freedom. So in this case, we're going to be using this motion sensor to measure it in this direction. So it's very important to make sure, once you're putting it on your specimen, you put it perpendicular to the specimen itself. For this experiment, we're going to place the sensor in the middle, kind of towards the bottom of the specimen, just so that the weight of the sensor itself has no effect on the frequency. Once your specimen is completely set up, the first thing you're going to want to do, just like the last video, is to run the test from the shake table, just to make sure that everything is connected properly and that you don't run into any issues when going into the actual simulations. Just navigate to the Shake Table 2 software folder, open up Shake Table 2 Test. You are first going to ensure that your base plays in home position, so slide it to the right or to the left until that green LED lights up. From there, you're just going to grab your emergency stop button, hold down the small red button, and then click the white arrow in the top left corner to ensure that the program's running and connected. If your home and amp LED are lit up and your status message says connected, you're all good to go. Click the push button in the bottom left corner that's labeled pulse motor, and just make sure that your base plate pulses to the left until it's out of the home position. If it does so correctly, remember to hit stop to stop running the function, and then close out of the program. From there, we're going to move over into our MATLAB program. Just a quick heads up, please do not mess around with the MATLAB code or uncomment anything. So please don't close out of the MATLAB programs when you're done. It does take a little bit of working around to get everything back up and running. So even when you're done with the test, just leave everything open and you're good to go. So the first program that we're going to navigate over to is called QSignQ8USB. It's a MATLAB function. Along with that, you're going to open up the floor 1 acceleration graph right next to the program. So for assignment 7, we're going to have a specified amplitude and frequency, but once you guys are moving over into your final project, this is where you can change these values around depending on what earthquake you're using. If you look in the white dialog box on the left-hand program that you have open in MATLAB, you can see that there is an option to change the amplitude and the frequency. So for assignment 7, we're going to make sure that our amplitude is 0 centimeters. So if you just double click on it, another dialog box will pop up and you can adjust the values. So you're going to want to set this to 0, along with a frequency of 1 hertz. As you guys know, if an amplitude is set to 0, then your shake table obviously is not going to move. For all intents and purposes, since you guys are measuring the natural frequency of your specimen, you're obviously not going to want the shake table to move whatsoever. From there, you're going to navigate to the taskbar on the top of the MATLAB program, click Quark, and then click Build. From there, you're going to go again to that top taskbar, navigate to the icon that's composed of 1 blue and 1 green circle with black arrows inside, and click that. Essentially, that connects the program to the amplifier and then to the shake table itself. Once that's done compiling, the icon next to it, which is a green circle with a black arrow in it, is going to light up, and then click that to play. As we said, since the amplitude is set to 0, the shake table is not going to move whatsoever, but in order to measure the natural frequency, you're just going to give a small pulse to your specimen, just like we did in the phone experiments. When that happens, the graph on the right is going to change because it's representing the acceleration that your sensor is measuring on top of your specimen. What you want to do is give your specimen just a couple more pulses so you can grab some good data from the graph. 2 or 3 should be fine, just like when we were doing the phone experiments. Make sure to give your specimen some time just to return to its natural oscillation, just so that when you do start recording data and looking and observing the graph, you can have a couple good data points. If for any reason the sensor moves while you're running the graph, just put it back in position and start the program over again. Once you guys have obtained some good data, you can just maximize that graph that's on the right-hand side and navigate to the top taskbar that's on the graph. Click the icon that's composed of a small box with 4 arrows in it. Essentially what that's going to do is scale your X and your Y axis so all of your data is centered within the graph on the screen. Just like your phone experiments, this should look really similar to the graphs that you guys created with your Excel sheets. From there, it's going to be pretty similar to your phone experiments when you find the time in between the peaks in order to find the period of the specimen and then calculate the natural frequency. The one thing that's really helpful in this MATLAB program is that there's actually a tool to help you guys measure the exact time in between two peaks, so you don't really have to estimate it as much as you did with maybe the Excel graphs. So what you want to do is navigate to the top taskbar and click the icon all the way to the right that is a box with a small ruler inside of it. Once you click on that, you'll see that two white vertical lines will appear on your graph, one labeled 1 and one labeled 2. What you want to do is grab the first white line on the left side that's labeled 1 and just center it on one of the peaks of the sections of data that you're looking at on the graph. And from there, you're just going to grab that second white line on the right side that's labeled 2 and drag it to the second peak. And as you can see, that dialog box on the right side of the screen gives you a bunch of measurements that correspond to the two data points that you have your line centered upon. And underneath those data points, you'll see the change in time labeled right there for you. So use that when you're calculating your period and then calculating your natural frequency. The last thing that you're going to want to do before you finish out the experiment is once again navigate to that top taskbar, click File, and then click Copy to Clipboard. Essentially, that's just going to take a quick snapshot of your graph, and you can email it to yourself just for future reference and for when the professor wants you to submit it with assignment 7. One last thing to note before you guys finish out the experiment, please remember to not close any of the MATLAB functions or the acceleration graph that's on the screen. Every single time a new group comes in to run the experiment and they run the control test, everything will completely reset, so there's no need to close anything out. It just makes it a lot easier when new groups come in after you guys. And then you're all set.